In this presentation, we are going to look at binary search trees. So the question we're asked is as follows. Oops, went too far there. A binary search tree is designed to store an 1, 2, 3, all the way up to 10,000 at its internal nodes. Draw levels 0, 1, and 2 of this tree, showing which number record is stored at the root, and at each of the nodes at level 1 and 2, making it clear which records are stored at each level. So let's start off. We have to identify the root node. And the way we do that is we use this little formula here. The floor function of n plus 1, where n is the number of items, its n is 10,000, from up there, all over 2. So this is the floor function of 10,001 divided by 2, and that is equal to the floor function of 5,000.5, and that's just equal to 5,000. Okay. Now, just as a quick remark, I'm going to sort of skip past this, is that when n is an even number, this works out to be just the average of, it's just half, this identity here just works out, you just have to divide the number by 2. It's when you have odd numbers of n that you need to sort of use this formula. So that's great. So in level 0, the root node is 5,000. So what about level 1? What are the two child nodes of the root node? So what we have to do here is on the left hand side there will be 5,000 nodes, and on the other side there will also be about 5,000 nodes. And so what we have to do is find out the node numbers of each. So let's look at the left hand side. So there are 5,000 nodes on the, or there's 4,999 nodes, because I'm actually already counted the upper node already. So there's actually 4,999 nodes on the left hand side. So the 5,001 is not part of the left hand side subtree, and the other 5,000 are in the right hand side. So in this case the floor function is 5,999 plus 1 all over 2. So essentially it's 5,000 divided by 2, and that works out to be 2,500. Okay. The right hand side, the node of the root node of the subtree on the right hand side is essentially done the same way. There, the first node is 5,001. The last node is 10,000. So there are actually 5,000 nodes. So it's essentially it's a 2,500th node between these two. So essentially it is, the root node is 7,500. Essentially all you have to do actually is just add the number of the node above it to find the corresponding node on the right hand side of this, on the right hand side subtree. So that's that one there, 5,000, 2,500 and 7,500. So what we're going to do for, that's a level level 1. Now we have to go down to level 2. Now essentially what I'm sort of saying is that we have to find one of the nodes. So we'll find the left hand side, the subtree on the left hand side, and then what we're going to do is add the number of we're actually just add 2,500 to each of the repeatedly each of the values, just to find all 4 of the nodes. So on the left hand side subtree, there are going to be 2,499 nodes. And so what we have to do is find out the root node of this. Again, 2499 plus 1 all over 2 that works out to be 1250. So that is the left-hand side subtree of 2500, that one. And so the other nodes are as necessarily, we have to add on 2500 that, 350, add on 2500 to that, we get 6250, and then finally 8750. Okay, so let's just draw this out properly. That's the next question actually. So level 1, level 0, level 1, and level 2. Let's just add them all, draw them all together. So what we have to do is indicate properly which is at each level. So we have level 1 or level 0, which is up here. And that's the node number 5000. This is level 1. That's node number 2500. And this is node number 7500. Down here we have level 2. The node number here is 1250, 3750, 6250, and 8750. Okay. There are actually more subtrees after that. We're not asked to draw them, but they are there. You just continue the graph down like that, the tree down like that. So we just put the incomplete little trees there to represent that. Now, that is the first part of this question. It's actually quite long, but what we have to do is the second part here. What is the maximum number of comparisons that would have to be made in order to locate an existing record from the list of 10,000? Well, the way we would calculate that is as follows. So the ceiling function of n ceiling function of log of to the base 2 of n plus 1. Okay, and that is the ceiling function of log to the base 2 of 10,001. That works out to be the log to the base 2 of 10,001. That works out to be 13.28. So the answer is the next highest integer up from that is 14. So that is the answer to that one. And so that's the maximum number of comparisons that would have to be found to locate a record. Okay, that ends our presentation.